Quantum mechanics, at its core, is a change to the rules of probability. And this is also where the power of quantum...
This is what you do in the famous double slit experiment. You close one of the paths, and then you see that now the thing that previously never happened now can happen.
And the two slits. Because here we have something that produces light. And the light passes through two slits, actually very close together, because light has a very short wavelength, a very small wave. So you can't actually see these two slits, but it's the same idea. And then the light passes on and hits this screen. You can actually see a pattern that's quite similar to what we saw on the tank with the water. And there are regions of bright and dark and bright and dark and bright and dark. Because here we have something that produces light. Something that produces light. Something that produces light. Something that produces light.
Remember, you heard it here first.
In 1960, Ted Mayman demonstrated the first laser by taking a cylinder of ruby and surrounding with a xenon arc flash lamp used in aerial photography. An intense burst of light from the lamp initiates lasing. To see how it works, let's look at what happens with a weaker lamp. A flash would promote a few electrons from the ground state to an excited state. They'd lose a bit of energy, fall to a lower energy state without emitting light, and then drop from there to the ground state, giving off a burst of light. The light produced would be incoherent light, a spectrum of colors and intensities, just as my small laser made the ruby sphere glow. To create a laser takes an extremely powerful lamp. In the ruby laser, repeated flashes, called pumping, make something amazing happen. They supply so much energy that a population inversion occurs. Here, more electrons in the energy level just above the ground state than in the ground state. Electrons from a population inversion returning to the ground state release light that starts an avalanche called stimulated emission. The photon produced when an electron decays induces other excited electrons to simultaneously decay and release nearly identical photons. That creates coherent light.
An electron gun. Now, in order to keep the universe balanced, electrons like to go from where there are too many of them to where there aren't enough. A power supply connected to the gun supplies electrons to a heated metal plate at the back. It's called the cathode. The same power supply steals electrons from another metal plate at the front. It's called the anode. Because of the heat and the charges provided by the power supply, the electrons zoom off towards the plate at the front. When they get there, there's a big surprise. There's a little hole in the plate. And they go shooting out into space in a stream.
Illustration. Here I have a ball on a string, and I whirl it in a vertical circle. If now at the top of the path, let us say, or at the bottom of the path, I let it go, I cut the string, does the ball go radially outward from the circle? No, it does not. It goes tangent to the circle at the place in question, like that. I'll show you that letting it go at the top.
Now, if you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you.